At, for instance, that picture right here with an 1100 degree burner on the cable coating, you're seeing the energy consumption of the cable coating being taken, so it stops the flame spread on either side, and also it doesn't affect the running capacity of the cable, whether it's in its cured non-fire state or if it's under fire, up to 90 minutes. So what is the coating? It's a water-based, no solvents coating. Its standard colour is white. You can tint the coating, but the more, up to about 7.5%. But the more you tint, the less fire protecting additives you have. So you're actually bleeding out the coating when you're tinting it. Non-toxic, non-hazardous, has a density of approximately 1.3, so 1.3 grams per cubic centimetre, and 70 to 75% solid. So it's quite a thick paint, considering house paint is around the 15% solids. Shelf life of 2 years in its wet form, so if it sat around for 2 years before it was sprayed, it's still a warrantable product. We package in 25 kilogram pails. We have interior and exterior applications, and also hydrocarbon. It can sit in hydrocarbons, then dried. It can sit under water and then dried and still fully function. That's actually part of the FM test, that if it's in an exterior application, it can be completely wet, then re-dried, then burnt, and it still functions exactly the way it's supposed to. Water and saltwater resistant, resistance to fuels, oils and chemicals. It does not derate your cable system, which I'll move to in the next. And it's an ablative non-intumescent, so it does not expand under fire. We do have intumescence, our FS11, which you saw a video of, but this does not expand. It has an energy consumption chemical reaction. And we can apply this by spray or brush. So when we zip back to what we were looking at with tests, a lot of the tests, we get a lot of the time, a customer will say to us, can we please have your tests on your 220 kV high voltage cables. We don't really do tests on larger cables. It's actually better to do tests on smaller cables because of the mass of the cable. If we can protect a 50 mil diameter cable with 1 millimeter cable coat, we can definitely protect a 200 mil diameter cable with 1 millimeter cable coat, because there's less product within that 50 millimeter, so that fire will get to that cable at a quicker rate. So we do not derate a cable or a cable tray. So derating a cable will run at a certain temperature, and when you cover that cable, you'll actually create heat because that temperature can't get out of the cable and it can't run and function properly. So what that facility or what the asset owner will do is turn down the function of that cable. And if that cable's not functioning at maximum capacity, it's not doing its job. So one of the things that we're consistently asked for is, do we derate, if they apply the coating to cables, does it derate the system? So no, it doesn't, and we're tested for it. Third-party testing, not our testing. So effectively what we do is that when the coating is applied to a cable surface, you're extending, and this is a non-insulating coating. So what you're doing is extending the cable surface itself, which you're giving the cable a greater area of heat dissipation. And what you'll see on that the cable that was floating around, it's actually bumpy, it's not smooth. So you're actually, in micro format, you're actually creating a greater area, so the surface area is again consumed. So we extend the cable surface or the diameter of the cable, which in turn gives the cable a greater area of heat dissipation, and the same applies to a bundle or a cable tray. You're still simply extending the surface. So with the low dry film thicknesses and spread rates of FS15, also FS11, we have a different chart here for 15 to competitors that we find sometimes. We don't find a lot of competitors on sites, mainly because we're always on the sites. But for 15, we have a dry film thickness of 1 millimetre, Industry standard is 1.6. Our spread rates without wastage are 1.85, and the industry standard is 3. The same applies to adding 30% approximately to a wastage factor. The dry weights on trays compared to the competitors at 1.2 to 1.75, 62% saving in product used. Now, the 62% means the saving in weight, the saving in cost, lower freight costs with smaller quantities, less man hours to install, shorter contract times. And when you're looking at overall coverage, us supplying 25 kilogram pails, you get 13.5 to nearly 14 square metres in surface area of your cable coating compared to 10 square metres of your competitors. So on average, 3.5 square metres is quite an area of installation. And for the application, the cables definitely don't have to be new. We don't do a lot of new installation. We usually come in after the fact. All of our applications are in situ, so they're all done in place and live without business interruption. And for us, we have to make sure, in applying the product, that we have to make sure that the cables are clean and free of dust and oils. If there's a heavy amount of oil on it, we'll use a watered down solvent to get that oil off, because we simply need to stick to the electrical cable. So we spray a very light coating onto the cable for adhesion, and then we spray or brush a final coat. Majority of the time we spray the coating because the finish is always better, plus it's a lower amount of contract time. Brushing the coating, although it's still going to do the same thing, is a very ugly application. It just does not look good in the end run. So for cables in trays, you do not need to coat every cable, only the exterior surface of the tray. Once the tray is coated, there's no oxygen between the cables for the flame to ignite internally or burn. So flame will only spread on the outer surface of the tray and or the cable. Then having the cable coating there, which is zero flame spread, means that the flame will simply not spread at all. And these are the types of machines we use. Minimum 3300 PSI, Gracos, LPCs, so there's quite a few in the market, but we recommend Gracos simply because they're worldwide and all of their parts are everywhere. So for applications or types of applications of coatings, fairly typical application is a fully loaded tray where we simply just coat the exterior surface of the tray, so flame will not burn along the surface. If we're finding cable trays here like this with a certain amount of cable in it but not fully loaded, then we'll only do the sectional area of it. There's no need to spray over here. And you have to remember, we're only here to protect the cables. When cable trays are against walls that you can't get access to, we will fill the back of it with rock wool and then spray down the sides here so there's no fire ingress into the rock wool. And we do this, that means that there's no cable coating at the back here of this tray. But that doesn't matter, because what you're doing once again is stopping the oxygen from being in there. So once that's stuffed in there, there's zero oxygen in here, which means that there's zero flame spread again. When you're in a trefoil situation, which we saw a picture of a few slides back, we're once again just coating the external surface of the tray, or the cable itself. And obviously in single format, just the single cable. So how we specify or how we quote 15. So in calculating or specifying or quoting FS15 or any other cable coating for that matter, you must calculate based on the metres squared, not kilograms or pails. A lot of the time we'll get emails or questions saying, can you please quote us for 25 pails of coating or drums of coating? But usually the person asking the question has lifted that off a specification. They don't even know that with 25 kilograms of 25 pails, that's 13.5 square metres times 25 is their spread rate. So we always come back, usually without a price, and always ask what's the tray size, the widths, the heights, so we can get an understanding of their application or their requirement, and then we inform them of what they require. Because the majority of the time, most suppliers will come back and just give them a straight rate and a freight rate, and that's the end of the requirement. But a lot of the time, we'll find that an engineer on site, they may not necessarily know exactly what they require out of it. So if we can't get to site, we'll get pictures from them and then give them a bit more clearer direction on what they require. And one of the other reasons is other suppliers and manufacturers, they package in various packages of 15, 20, up to 35 kilograms. So a 25 kilogram pail price is very different from a 35 kilogram pail price. So asking for metres squared or getting that information is paramount to understand what the requirement's going to be. So if you base your requirement on metres squared or surface area of tray, or diameter of single cable, you'll always get the correct quantity required. And to break that down, for instance, if we get a request only for a quotation of 5,000 kilograms of coating without area, the ratios are very different. For FS15 or FS11, our cable coatings, 5,000 kilograms is 225 kilogram pails, and that will give you 2,084 square metres of surface area, including wastage. For one of our competitors, or nearly for all of our competitors actually, 5,000 kilograms is 250 20 kilogram pails. So this will give you a total of 1,112 square metres of surface area. So having only pail sizes to quote from, or I require this size only, doesn't really give you the full information that you require. So although 15 will cover usually twice the amount of cables than its competitors, that's application dependent too. For us, we will only require from you the width, the height and the length of the tray, or the OD of the single cable. And that's all we would need to get an understanding of your requirement and how to price it properly for you. But mind you, if it's 30 metres in the air, we probably also need to know that as well. So only quoting metres squared will keep the product quantities based on your actual requirements and not on kilograms of coating. And that will, of kilograms of soap, yeah. So you don't want to order, or you don't want your customers ordering excessive amounts, because it's just going to sit there and do nothing. So giving us the right information will get you the right amount of product and the right solution. And regardless of us, always, it doesn't matter that it's our solution or our products. When you're getting passive fire protection quotes, always ask, does it include wastage? Most of the time people don't include wastage in their price. And if it's not included, wastage is not included, and I know there's some applicators in here, you're spraying a round surface, especially with a cable. So you're going to have a lot of wastage, usually 1.3. So, I mean, it's a pie solution. 30% you'll lose simply because of a round cable. It's not a flat surface. So getting, even penetration seals, there's wastage. So always ask those questions, because at the end of the day, when your customer's getting their work done, the applicator has run out of money. Although he's got the contract, he's run out of money and then comes back and says, I'm 20% short, or your contract's not finished. And you're like, no, you gave me a supply and install price. Yes, but I didn't include wastage. So then your argument starts. So always make sure that your contractors include wastage in their works. So some types of applications that we have here, and all being industrial, to bottom-fed switchgear, large areas, open areas that people aren't willing to lose their cables and don't want flame spread to other areas. Basement areas. Notice that these are direct-fed conduits in a cable gallery. We've kept them open. A lot of these times these are sealed up, but there's no point to sealing them because of the water ingress. And most of the penetration seals on the market don't have pressure and head for water behind them. So you have to, unfortunately, let the water come out. But what they've done is they've coated the cables in this scenario, so there's zero flame spread down through the cable and up into the yard or up into another area, and vice versa as well. So the cable, the cable conduits are open for water because it's below ground, and the cables are coated for no spread of flame, and these don't need to be sealed or fire rated because we've used cable coating to stop that flame spread. No other typical applications within basement areas in cable galleries, and also in a switch room. So the switch gear is actually, or the cables are coated not only in the tray, but also for the droppers coming down onto and also coating the glands. So if this facility lost this switch gear, it's a switch gear change, it's not a cable change. We were at Alcoa yesterday, and they informed us that one of the high voltage cables that they lost in a fire was a 4-month lead time before they could get it in, which they then got in 6 months. So that area was down for 6 months. The business interruption was horrendous. Was it 45 million or something in total?
It was a lot of money at least.
So that's a massive business interruption that doesn't need to be there. And you'll see here, typical non-coated cable on fire, and the cable-coated cable here with zero flame spread. That's black because of the smoke. So what you can do is just get a wet rag and rub all of that smoke damage off the cable coating. You don't need to cable coat it again; it's fine. So it goes to show you that, you know, with a lot of methods with fire protection, with fire stopping, and we'll get to fire stopping in a minute, unless you want to break for 5 minutes. Cable coating is definitely the answer for zero flame spread and to save the facilities. Now, this is still applicable, and comes back to assets as well. It doesn't mean, although I talk about facilities a lot and in industrial applications, the same applies to an office building, the same applies to a church, the same applies to anywhere there's an electrical cable. Because if your cables are coated, there's zero flame spread. There's zero business interruption. There's always accidents on sites, and there's all with fire, and there's always, especially, you know, the fire brigade will know. If in an office building, there'll be a cable fire in a basement. And that means that whole building's gone. There's no electricity to that building. At the moment, for instance, we were talking about yesterday, London Underground. They had their King's Cross fire. It started with cigarette butts onto old timber underneath the escalators, spread to the cable systems and engulfed the whole train station. We've met them several times, and that's why we've just finished a whole raft of tests for them. But the engineers that we met there said, no, we have risk assessment on our cable systems, and they don't need any further fire protection. And that was 6 months ago that we met them. So we got their test data and we got their requirements, and we did our own tests for them. But then I'm meeting them in a month. Now they've had a fire for 3 weeks, a burning cable fire in sub-basement in another train station. So their risk assessment doesn't work. It simply doesn't work. So for 3 weeks a cable fire has been burning, and they haven't been able to put it out because they've got zero access. And they sealed it off. Now that's also not only PVC cable, but it's lead paper cable. Lead paper cable got, I think, finished making in the 40s. So, and that's asbestos wrapped. So that's the other thing. You know, you're starting to look at older cables and older buildings here. You can coat asbestos wrapped cables, and then they're sealed. Then they're fully sealed, and there is no egress of the asbestos fibres. So it's also another solution that you could look at. So we want to talk about fire stopping, or would you like a break for 5 minutes? There's a guy yawning up at that.
Det gjorde good. Floppen ikke.
About saving the cable, so you can run the cable after the fire.
Yes, after the fire, what we would do is scrape, not unlike the movie you watched, we would scrape away the cable coating, replace the burnt cable coating, because it never gets down to its final thickness, and that cable's still, and we'll be doing that while the cable's still active.
Yeah. But what about the aluminum cables?
The,
Manufacturers that fire through the cable, they say they can't do it for aluminum cable because the heat and the core expands.
That's right. What happens in a fire with the cable coating? The fire's impinging on the cable coating. The cable coating's going the other way, pushing the fire backwards with its chemical reaction, and it's also insulating the core. So
you don't get the heat.
Yeah, you don't get the heat on the core.
And you have the testing for that.
Yeah. That's the one thing I love saying all the time. We have the testing for it. So it doesn't matter